All right, so we have decided to do the panel in the middle, which I think is an excellent idea. And we're going to take questions from, of course, everybody in the house, all the VIPs in the house, and people online. I'll try to get to your questions. Do ask them. You asked great ones yesterday, but we're concentrating here. So who wants to ask this incredible panel the first question? Wow. There we go, man.
Here you go. Can be 5. Will you pass that down, please?
I'll try to generate a little bit of the controversy that we were asking for at the last QA panel. If you could magic yourself up just one tool to help you write better C++, and I don't know, maybe Chandler and the team in Clang's already working on this, what would it be?
In my work, I would love a way to sort of step through template instantiations without having to do it in my head. I can do it in my head, but it hurts. What I'm thinking of is if any of you have used Dr. Scheme, which is a scheme interpreter. As you evaluate the Lisp-like expressions, you can actually step through and see like replacement as you go, which models what the execution is doing. And templates, because they're functional, work along very similar lines. And I would love to be able to see that with the type defs and the parameters changing. And currently, it's an opaque process. You slam it in the compiler, and then you get an output or an error, and you have no idea what the intermediate steps were unless you've seen it a million times.
So, Stefan, like the template debugger that was presented at C++ Now in May?
This year?
In May.
I didn't attend this year. Yes, I want that.
And is video recorded?
Oh, awesome. Yes, I want that then. Clang has it. I didn't use Clang.
I didn't do it.
So my answer would be I really want a tool that will make sure that my header file, my pound includes, are the minimal ones that I have and not too few and not too many. So directly reflect my dependencies. That's what I want.
Just search for include what you use. It's
Yeah.
There's a project out there using Clang, if I'm not wrong.
Yeah. So include what you use was actually the very first tool we ever built on top of Clang, and it was so hard and so broken and so annoying to use that we're now doing modules instead.
Which brings me to what I wanted, actually. So I would like a tool, nay, a language extension that lets me not write include ever again, except for legacy compatibility. I understand someone is working on that, and this actually relates to one of the questions we got in off the internet live earlier in the conference, which was, so what is the progress with modules? So let me slide in that question since it relates. And whatever you can say about it, I know you guys have been working on it. Is there anything you can say? Because people really want to know.
Sure. Okay. So first thing I'll say is when I'm talking about modules, and I think when Herb is talking about modules, we are not talking about the modules that form shared libraries and teach the language standard about how linking behaves. We're not talking about that. We're talking about modules that is somewhere between what David has proposed for standardization and what Doug Greger has talked about at the standards meetings and has some limited amount of documentation about. Those modules are essentially a replacement for header files and textual inclusion. The status is that they work very well for C if your standard library supports the restricted model that is required to use it, and we only know of one standard library or one system that does, and that's OS 10, and it was after a prodigious amount of work to get there. It also works fairly well for Objective-C because it's just C. The early stages of making this work for C++ are working, and the status I can give you is that Richard Smith has successfully taken a lib C++ hello world with IO streams and compiled it using modules, and it compiled in, I believe, like 1/5 or less of the time.
And then we're going to want import what I use.
Right? I'd like a tool that adds a nice UI for things like, I worry a lot about like this function I'm working on, how hot it is. I'd like to have a notion of I don't know, color, something. I mean, some UI expert, I'm sure, can find a very neat way to represent this. How hard is the function, and following my edits, how, what's the cost of my edit, and stuff like that. That would be absolutely awesome for me,
I'm not a UI designer, but I have a suggestion. Use a different, cold to hot color gradient, of course. But the cool thing is, for the really hot things, have the text melt a little bit, and with a little animation.
All right. Next question, I guess. Next question.
Okay, I have question. The first question is, I saw that Microsoft is using a new keyword for function that they are resumable, and as I understand, the intention is to reuse the same threads. So, but our function was resumable from the very beginning, at least as I remember myself. So, and always it was handled on OS level. So why we need for this trick of reusable just a thread to change our language?
So I think you're asking, so there's the resumable keyword, which in the CTP we're shipping later this year, we're doing with double underbar, and this is also working its way through standardization, of course, would be without the underbars. And you're asking, why do we have to signal that? Aren't all functions resumable? No, they're not. Functions don't store their variables non-locally and return before they're done, before their side effects are complete. That is very strange behavior that nobody does, unless today, and the only place this happens in the standard today in a systematic way that you know about is if you return a future, because that's what that says. It is a form of asynchronous work. It's not quite the same, but it's very similar, because when you return a future, you're saying, I am not done yet. And so that's, of course, resumable functions, as has been pointed out, could be used for many other things, but especially for async operations, you'll notice one requirement is that you return a future. So by definition, it doesn't apply to every function. You can't rely on side effects being complete, for example.
Or I think set jump and long jump do that, and they're horrible.
Well, there's actually also one other language modification aspect that resumable does. I didn't go into a lot of detail there, but the return type of a resumable function is task of t or future of t. But what you actually return in the return statement is just t. You don't actually return a task of t. In order to do that, there has to be a language annotation saying this function behaves specially. It can't just be deduced at runtime, because the language itself is actually being modified by that resumable keyword.
Guys, sorry, I will add a few words more. So we have in standard future and async that do this. But as far as I understand, resumable was intended to do not just to do operation asynchronously, but for reusing the one thread between different execution flow. And that's why we saw in presentations that we preserve stack of execution, blah, blah, blah. Everything that is done when thread is switching from one thread to another thread. And that's what I meant when I saying that all our functions are resumable, because in any moment, OS decide to stop my thread, switch to another, blah, 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 come back later, resume my function, start working. Yes. And it is what thread is.
And of course, that's not the same thing, because first of all, you resume on the same thread, and second, nothing else will happen on that thread in the meantime, including that you won't return to your caller who assumes side effects are complete.
Yes.
It really is different.
Exactly, and that's what I am saying.
Now, having said that, let me talk about something very briefly related, which is that once you have this ability, the one thing that you do want, because it's a completely novel thing, is to be able to control where you resume. So again, this isn't being introduced by await and resumable, because you already have it when you do task or future.then. But to control where you wake up again and not use the default scheduler, that's where Google's and the Standards Committee's executor's proposal comes in. And that's why that's part of that same package being considered for the concurrency technical specification. So you can get a default executor, but then you can also take control over saying, I want to run my continuations there, if the default isn't appropriate.
Well, another important aspect of that is if you just have a thread that's being scheduled with the OS scheduler, that thread has to remain in memory. Everything below your function on the stack has to be retained in there. So you have A calling B, A calling C, calling D, and then the scheduler will switch you out, and your entire call stack of everything survives there. With a resumable function, that function itself is actually isolated. Only the memory in that function is actually staying around. The rest of the thread can go down. In fact, it can completely unwind. It can, the thread can terminate, go back to the OS, go back to the thread pool. You can go down to one thread. And at some point in the future, something that may happen that causes a new thread to come in and go and resume that function. So it's not just a matter of suspending an existing thread. The thread actually can disappear. All that happens is there's some state in memory saying, well, we can resume here after the thing that you're waiting for has happened.
Great.
So with an executor, executor, whatever. You could specify, for example, all of these asynchronous functions shall execute on this thread only, which means that in that circumstance, you could omit all of the synchronization primitives that would otherwise be necessary. Is that true?
Yeah, one of the executors that I think is still in the paper, although it's gone through a bunch of revisions recently, is essentially designed to provide synchronization at the executor level. And there are actually other ways of doing it as well. There are a bunch of different ways in which you can essentially embed the synchronization in the executor to ensure that there's mutual exclusion whenever one of the tasks is running.
So the idea is, instead of taking a mutex directly with the idea that I'm nailing ownership to a thread, you're saying, no, I want to have exclusivity follow the task, which follows the executor, right? Which you can't do with standard threads because they store a thread ID or whatever inside. But basically, think of it of mutex that keeps exclusion to your logical task, regardless of what thread it happens to be scheduled on as an implementation detail, which is a new concept.
So so there's one question for online, which kind of will shift a little bit to something else. So because you like to emulate some of the stuff C# is doing, which is actually great. In this case, C# also has the Roslyn project where you can actually program, the compiler gives you ASTs and whatnot, you can program against, blah, blah, blah. This guy wants to know, Alberto, is there some way to do the same thing in C++? Or is the standardized committee or even the VC++ team thinking about a Roslyn-like feature for C++?
VC doesn't even have an AST.
We're fixing that.
What about Clang, man?
Are you sure that this isn't Eric Niebler in disguise?
No, because Eric, there he is, right?
No, I know. I'm looking at him. Anyways, Eric has often pestered me about why Clang doesn't expose some way to actually hack on the ASTs, why there isn't a standard way to hack on the ASTs. It would let you do a lot of really crazy, cool expression template and metaprogramming stuff. And I am absolutely terrified of this. Not because I'm terrified of the programs that Eric would write. Those would be awesome. There's a specific problem here. We change the Clang ASTs on a pretty regular basis. They aren't even remotely stable, and that's just one implementation. I don't know how realistic it is that we would be able to come up with a stable, predictable, standardized AST synthetic representation in the standard, which each implementation could actually afford to produce and which the standards committee could actually support and maintain over time to enable this. Maybe we could, but it would have to be very limited, it would have to be very constrained, and it might have pretty high compile time overhead. So there's some challenges here. I don't know.
This is about introducing new syntax, creating new syntax.
Well, it's not just creating new syntax, right? It's like you essentially want to write an expression tree, but then like give it to some magical syntax which turns that expression tree into a compile time tree you can hack on, and like transform.
Back to asynchronous. With await, a function can be deferred and then find itself running on a different thread. Also, there is such thing as a thread local storage. How can it be mixed? Sometimes I want to use a thread local storage.
If you're doing anything with parallelism, don't use threads local storage, or sometimes it's legal, be very, very careful with it. And this is true no matter what parallel library or system you're using. This is just inherent in parallelism.
So no magic here. Sorry. Thank you.
Okay. Right now, the compiler gets a source code and spits out to one architecture per time. So if you want to run in ARM and Intel, we have to compile twice. There is any way, but the hardware right now has GPUs. You have DSPs. How about create some annotations in the code just to give some hints to compiler? Compiler takes this section here and compiles to different platforms and then link automatically to us.
Ifdef _m_ix86.
One pass.
One pass. Well, the code could be completely different. Like you can do crazy stuff with preprocessors. Yeah, I
find it very telling that we're talking about optimizing compile times for, like, essentially we're talking about just one parsing and then generate code for the code generation part. I find it telling that compilation times are such a huge problem that we're talking about, like, squeezing the last blood, you know, the last drop of blood out of the stone there.
What do you mean?
Because my understanding is that the problem is that compilation is so slow that people are thinking of ways to save on it.
Why is it that compilation is slow as opposed to it being kind of tedious to have to do n compiles instead of one?
Because it's slow. Right? I mean, it's you press a button, it's done. It's just it's slow. It's right. It's make.
My compile times aren't slow.
I think I have the microphone. To answer the sort of follow up on the question of how can we make something that we can make an AST and then we can do something with that without reflection. I mean, reflection is something that's supposed to be done. It's in the proposals for whatever this for the future of C++. Wouldn't that solve the problems? You say, okay, I'm going to, here I'm going to find out what type this is. I can do something. Presumably, if you can find out what type something is, you could say, and I want this added to it, and now make an object of this. Isn't that like related to that proposal?
So really soon I'm going to make Eric Niebler answer your question because I'm not going to know what I'm talking about. But I think reflection is kind of the umbrella under which this seems like an interesting idea. And I think that what you just described is essentially, I think that's essentially what like Boost Proto does. It essentially like lets you build expression templates, right? Which do as much of this as you can do today, but it's really horrible, it's really hard, and the idea is to find a way to make it easier and more powerful.
Okay. I mean, I was just trying to figure out.
I'm guessing. Like I said, I like you should ask the person who actually knows.
Do you have the microphone?
All right, so another question from online. This is from Tal Agman. With all due respect, this might actually translate back to something someone up there I know had talked about at some point in time before we were here. With all due respect to the great progress done so far, today using C++ still doesn't give me full exploitation of the hardware, but only a tiny percentage of what I can do. So how far are we from getting us to standardize it to be able to get more out of hardware? So in other words, I mean, that's somebody else speaking.
In what way? Is there, for instance, for portable languages, there really is no language lower in general purpose use. So is he talking about accessing GPUs? Is he talking about accessing vector units? What's he talking about?
It's a good question. What are you talking about out there? I think he's saying that he wants to be able to use C++ to get more out of the hardware. Right, that's his point. I mean, I know we were having this conversation. Maybe we were drinking too much.
No,
so we go to a different question, but it's something to think about.
I'll answer this one. Yeah. So, right now, right, I think the biggest thing is is if you're just talking about standard C++, there's no good way to get to the vectorization unit. There is some work going on in auto vectorization that's getting better. There's no good way to really utilize the GPU as a GPU thing. And there is barely a way to light up multiple cores because there's no standard tasking models. There's just threads, which don't scale particularly well. But I think all of those things fall under the category of we need better ways to express parallelism. And I think that's what you're seeing going on here. If we get a fundamental tasking model in there, if we get some standard algorithms that can do vectorization, possibly if we get some way so that you can restrict aliasing so the compiler can do a better job. You know, I think it's all being worked on, and hopefully will happen.
Is there or will there be a thread safe timer that will just call me back when a certain timeout is elapsed in the standard?
Stood this thread sleep 4 stood chrono milliseconds 500.
As in, I don't want my thread to sleep. I just want like something like a JavaScript set timeout.
Well, what does JavaScript set timeout do? Not all of us are JavaScript programmers.
So in the same thread, you just do a set timeout, and you can probably do like 10 of them, and for 1 second each, and then every time you do that, some callback will be invoked on the current thread, or on whichever thread that.
What
there's
else?
only one thread in JavaScript, so it doesn't matter.
I don't think that model necessarily maps to C++. Maybe other people know.
I mean, often what I've had happen is that I want a request or a query to time out after some time, and I've had to keep polling after a certain interval, and check if that timeout is elapsed.
Like a leave event kind of thing. It's
something like that. Yeah.
Yeah. I think it would be good for the folks working on the async stuff. A lot of the tasking models have this, where I can say the equivalent of async this task after this duration. Right, which just means it sits someplace in the queue. It's a delayed start.
So the executor's proposal has a scheduled executor interface, which lets you add after a certain amount of time. That's one half of this. The other half of this is different. The other half is cancellation after a certain amount of time. And cancellation after a certain amount of time is crazy harder because of the implementation constraints we're currently operating under in threads and so on.
When do we have decent refactoring tools in Visual Studio, or do we have to wait for Clang?
I said we don't have an AST.
And I said we're working on them.
Okay, we've got enums, we've got tuples. When are we going to have like full-featured algebraic data types?
I don't know, but I wish Lawrence Crowell were here because he runs the study group on numerics, and that sounds like something that would fall under there. Does anybody?
It's a variant.
It's a variant?
Yeah. You're talking about variants, right?
Not particularly, like list, it's either now or cons with bits of data and
referential data structures defined. Okay.
That's algebraic data type. I don't know, like in OCaml or in Haskell, it's very if you got pattern matching, it's very useful, and you can simulate it with classes and structs, but it's really tedious, and if you just have it, it makes trees and many things very very easy.
I mean, a general comment would be that different languages have different ethoses. Is that the word? Ethai, the plural is of ethos. So each language has its own ethos, and I hear what you're saying, but it doesn't seem like it would be something, a slam dunk for C++ thread at this moment, and it would be just an odd appendix to add to a collection of the C++ way would be to say I'm defining the list with a pointer in it and all that stuff, and I use private data, and but there would be no easy self-referential definition that's 2 lines, and there will be no pattern matching and stuff like that.
So here's a concrete suggestion. What what problems do you see C++ programmers facing today that would be solved by this? And when you have a concrete idea of what those problems are, sit down and write, a sketch of what it is that would solve it. And when you do that, put them into a document and mail it to the committee.
Cool, thank you. I will.
And to be more specific about mail to the committee, isocpp.org/std gives you the information how to submit a proposal. We created a forum for that last year through which proposals have already come and are going to be considered in a couple of weeks in Chicago. So please take a look. We'd love to hear from you.
The reason I say this is that I think it's going to be very hard for any of us up here, especially on a panel, to really necessarily understand exactly what you're aiming for, like what problems you're going to try and solve and how it's going to help. But if you actually take the time to write down that explanation and kind of walk us through it, there's a decent chance that it'll become much more clear.
Oh, okay. I just thought that very many people in committee. I just thought maybe someone already had this idea.
Never assume that the committee has already had the idea, or if they have had the idea, assume they haven't had time to write a paper about it.
Hi. My name is Eric. I work with the C++ community, and one of the things that I hear a lot going to conferences is people with existing code bases. They're wondering why they should move to C++ 11. What is in it for them? So given the experts we have down there, I was wondering if a few of you could chime in short sentences, give your advice. Why should someone with a large code base using something that's not C++ 11, what is a motivator for them to move to C++ 11? Thanks.
Performance, correctness, clarity.
Those are the exact 3 words I was thinking.
I'm apparently, channeling Herb here.
Yeah. I'd add to that. I've been going through ASL, which is the Adobe Source Libraries, and updating it to C++ 11, and I'm probably cutting out half the code. So it's just a huge reduction. There's a lot of complex expressions, type expressions that just go away with auto. There's lots of things where I just have objects that vanish because I can use a little lambda. Range-based for loops, trim things out instead of having this big complicated for loop with a bunch of iterators or trying to map things into STD for each. So yeah, I mean, I have to say as somebody, it's like using C++ 11 is like using a new language. It's a lot tighter.
So I agree with what STL has said very succinctly. Wish I would have come up with it myself. But I have one thing to add to that, which is, by the way, where's the engineering text? Okay, thanks. Developer retention. You see what? I mean, I'm very serious. I mean, there's a lot of people I meet, in the hallways here and subway and street, and I talk to them like, what do you think? And like everybody's like, oh, I'm using GCC 4.2. I'm using this ancient Visual Studio 6, or it wasn't even Visual C++, right, or whatnot. And we're using this because of this management, whatever, stuff. I'm not going to repeat exactly what. And essentially, there's gonna always be there's always going to be some excitement about kind of being up with the cutting edge and being up with what's going on. And the notion of our shop is staying modern, is moving to C++ 11. It's kind of keeping with the trends, and it's doing the right things. And this varies a lot. Engineers put a lot of, I don't need to tell you guys this, right? People care about this stuff a lot. And for us at Facebook, the GCC can't release and Clank, they can't release stuff fast enough for us to use it. Because we are on it like white on rice. You wouldn't believe it. So this is, developer retention.
It's tools, right? We're craftsmen who use tools. Would a carpenter listen to you if you said, no, you shouldn't use a nail gun? Like, why should I use a nail gun, this newfangled thing? Like, you don't have to ask the question. It makes my life faster, more correct, more accurate, and those are the same reasons why to pick up any new tool, and C++ 11 is such a new tool with great compatibility.
So I'm going to add one point of clarification when Stefan said performance. We actually had a fun experiment. We turned on C++ 11 at Google, from cold. So we didn't have any code that we had authored that was using any of the features. And I can't say how big or how many dollars were attached to it, but let's say that the performance improvement was noticed in a very significant way. And that is just because we turned a switch on the compiler and picked up move semantics in the standard library. There were no movable types in our code.
You guys still don't use exceptions, do you?
I have a bunch of snarky
remember
comments that I'm
vaguely.
going to hold back there.
When are you going to use? Never mind.
So I'm speaking as a user, not a language designer, but I think C++11 will allow more of your developers to write more correct code in the language than pre-C++11. I just think it's just a much better tool, and you'll bring many more of your developers along, and they will be much more successful doing it than in the previous dialect. Would you guys agree with that?
Hi, I'm Home, and I have a question about variadic template. So I was wondering, is there a way or plan to have a way to directly apply raw string literal to variadic template, like expanded literal strings to variadic template?
I believe the notion of allowing templates to process string literals has come up in the committee. I forget why core doesn't like it yet. I have certainly wanted that ability from time to time. And you can almost see the glimmerings of it in the user-defined literals, where you can write the raw literal and you can crack open and get the characters. But something about the linkage, or I don't know what it is in core. Like as a user, I totally want that, right? I don't know why core won't give it to us yet.
I just love that when you asked that question about advanced templates and raw string literals, that Andre handed the microphone immediately away to STL.
Okay, thank you.
So this is more of a question about Windows, but now that Microsoft has started to have ARM-based programs, and a few years ago we had x64-based programs, what reminded me of the gentleman over there talking about, well, to me what isn't annoying is having to compile for these different architectures, is as a user having to find the correct binary. OS 10 uses something called fat binaries and allows you just to say, I just want the binary and to choose the right piece. I was wondering if there's any thoughts that kind of capability has been making that into Windows in the future, because I think it would help a lot of users. Plus, I think you also could maybe take it one step further and even have different code resources for different processors so that you could optimize for different code paths. That would maybe help as well. And you already have infrastructure there with the COF format where you can swap in different code sections. So I just was wondering if that's something you thought about doing.
It looks like Chandler will like to answer for Windows or non-Windows, but I'd like to pass it to Eho too, because store apps do that now, right? They're fat binaries, and if you're on x86 or you're on ARM, you just install the app and it just picks the right one. So some of that technology is there.
So are they really fat, or does all the logic happen at the store?
The logic happens at the store. So that's part of the packaging model. As far as fat binaries in the OS as a deployment mechanism, fortunately, I'm not the person who would speak to that. And even if I was that person, I might not tell you. So I'm sorry about that. But I will say this, that when we look at the market and we look at emerging countries which we're interested in, and we look at low-cost tablets with not very much storage on them, the trend is not towards bigger binaries. The trend is actually towards smaller binaries. So I'd say there's a countervailing trend here that might work against your desire.
Okay. But why stop at fat binaries? We could go all the way to like a bytecode, like a portable byte.
What conference did I come to?
And are you sure that LLVM doesn't stand for low-level virtual machine? No, sorry.
Yes, I am.
But I think that the answer, there is a countervailing trend. We want smaller, but I think it's the packaging and distribution layer that will help with that, and that's what you're seeing, say, in App Store kinds of models.
Also, I have a relatively unpopular opinion. You could solve 1/3 of the problem by stopping targeting x86. Kill it now.
Yes.
Yes. Yeah, 32-bit, like kill it, and then, Only 2 architectures to worry about.
32-bit address spaces are the root of all evil in dynamic analysis.
Who cares?
Hi, I just graduated college, so my question is kind of about that. With each new release of C++, it seems like there's more and more to learn and stuff. So how do we make it something that's easier to teach to new devs and something that's, I don't know, not so complicated?
I don't want to grab the mic all the time. Short answer is sometimes adding an abstraction simplifies your code, because instead of coding it by hand, you can actually express your intent directly. So having additional features actually cuts his code in half. And that actually means you end up with simpler code and being more productive. So that's how adding features can make a language simpler if you're adding essential abstractions that people would have to code by hand otherwise.
I just wanted to say I disagree. It doesn't seem to me that things go that way. It's C++. It is a language that is large. For the most part, for good reason. It has to have all this contact with the silicon, and there's a few unforced errors that have been made, and it's probably larger than it could, but that's par for the course for any language. Every language has some unforced mistakes in it. But I don't think this. We add features, and therefore the cat is going to eat the mouse, and the dog is going to eat the cat, and the jaguar is going to eat the dog. And I don't think things go that way, because you're going to end up with a bigger problem. And I think the illusion that you can write a large C++ program without actually knowing pretty much how it works, how the language, how it ticks, this whole model and the whole thing. I think it's an illusion that works until you see the first compile time error. And it may linger a bit more until you have the first runtime error. And you got to understand what's going on, because if you don't understand, you can't. You see the error message, and there's notions in the error message that you have no idea about. You can't code that way.
So I'm going to contradict myself in like 3 sentences here. First is I'm going to plug Bjarne's new book on, what is it, this tour, his tour book, which is a nice little book as an introduction to C++. And I somewhat disagree with Andre in the fact that I think C++ 11 actually has an easier entrance to start to teach. There's kind of some of the rough edges are smoothed out, and you don't have to talk about the oddity of type defs, and you can just use using clauses, which have a more familiar syntax and look more like assignments with types, things like that, just little things like that, in range-based for loops, and give you better training wheels if you're teaching the class. Now, at the same time, I'm a firm believer that if you're a professional engineer, you should not only own a copy of the C++ standard, but you should read it cover to cover twice. Okay.
And backwards too.
And I say that about any language. If you're a professional Java developer, you should get the Java spec. You should sit down in the evening and work your way through it, or whatever language you're working in, because I think it's important as professionals that you really come to understand your tools, because you'll be a much better developer. So.
I would slightly disagree with that. I read the standard for a living, and I don't know how useful it would be to blast through it in a single sitting. The core language alone would terrify me. But I do find it extremely useful to have a copy of the standard or a working paper that's close, open, and whenever I have a question about how something works, I go try and look it up myself before asking somebody. Now, in my case, that somebody is usually a compiler dev, but for other people, would be asking on Stack Overflow. And every time you have a question and you go look it up and you can figure out the answer from the standard, now you've encoded that little bit into your brain and you just add it over time, and that's how you really gain a deep understanding.
All right, so we're going to take a question from online, then we're going to go back there, then we're going to go there. Cool? So this is actually interesting. It's kind of a two-part. So you guys, I guess, do you use C++ 11 in your compiler implementations, front end, back end? And then also the question would be, because we were just talking about how great C++ 11 is in terms of performance. The question I would also ask, or not me, this person, is asking, why don't you? What is the technical reason that you're not taking advantage of modern hardware in your compiler? In other words, why aren't you using the GPU when you compile? So that's a two-part question. Are you using the modern stuff? Blah blah blah.
So, are we using C++11 inside of any part of Clang or LVM? The answer is yes, we do. We don't rely on it. We have a bunch of really horrible macros and a bunch of really horrible hacks to allow Clang and LVM to be built without C++11. It runs very, very measurably slower without it, though, because it's not just a standard library at that point. We're actively using move semantics and other C++11 tricks to try and speed stuff up, and it makes a huge difference for us. Have we looked at leveraging special hardware for the compiler? I actually asked a friend of mine who works at NVIDIA and understands how GPUs work, because I frankly don't understand them as well as I should, whether this would even be possible, and he looked at me like I was a crazy person. and like we kind of stared at each other for about 5 minutes as he digested this insane idea. And after that, he said maybe, but probably not. Understand that the compiler is mostly bottlenecked on memory bandwidth, like getting the data it is processing into the chip, and on the horribly branchy and unpredictable nature of compilers. We have somewhere around 45% stalled cycles in the front end of the CPU when compiling C++ code. That's 45% of the CPU that we're leaving on the table. And it's not because we haven't tried to fix it, right? It's an incredibly hard problem. I don't know how we would effectively distribute the work across heterogeneous compute layers. But if you do, it's an open source project.
Well, from a Visual C++ perspective, I think one of the things that we need to do before we can really embrace C++11 is to actually use C++ inside the implementation of the compiler. Most of it so far is C, lots of macros. We are actually working on that. The new features that we put into the compiler, for example, await, is using C++11, and that's one of the things about C++. We can have a huge code base. Most of the code base is still legacy, and the new features that we bring online, we can actually use the latest technology as long as it's a sufficiently isolated feature. So we're definitely going through a bit of a revamp right now to use more modern concepts inside the compiler. I'm sure we'll use a lot of C++11, but at the moment it's mostly C.
And you answered the GPU part, and that's still kind of a researchy problem as to whether that can be done usefully, because when you're blocked, when you're I/O bound, then adding CPU isn't your bottleneck. But for several releases, I don't know about other compilers, but at least Visual C++ has supported parallel builds. So we definitely, if you have a 4 and an 8 core machine, we'll definitely do compilations in parallel, different projects or different files in your project. Presumably GCC and Clang do that too.
We use build systems, but yes, it's the same result.
Meg-J.
Great. So we have a question back there.
So Herb, yesterday in your keynote, you had a graphic where you compared the relative size of C++11 versus the .NET framework and Java. Is there a risk with the number of current working groups that the future language will explode in size? And
well, remember that the left-hand side, where they were all the same within a couple of percent, was the language side. So they all have relatively equally complex language specs, lengthy language specs. It was on the library side where there was a big delta. And is there a risk there? Yes. I mean, it is, as I mentioned, it is both a benefit and a drawback that there's a big standard library in each of those, because they tend to be monolithic. And so as they get larger, especially using big OO class hierarchies rooted in well-known types and interfaces, things start to get straitjacketed after time, and it gets harder to maintain. They ship as a whole unit. They're tightly coupled. one of the things we have working in our favor is, first of all, we're smaller, so we're getting bigger and we can learn and try to avoid that, but it's clearly a danger. But we also tend in C++ to write loosely coupled libraries. Look at STL, containers, iterators, algorithms. Containers and algorithms, iterators are in between, soon to be ranges as well, and they can be independent instead of tightly coupled. That, I think, will help us to avoid some of it, but yeah, there's going to be some tax and some drawbacks to being large. But I think right now we're too much on the other side of it, not having enough in the box.
Yeah. Jim, you told about vectorization optimization, and you said that you generate two versions of code with vectorization and without, because the function may be run on different hardware. So there is a runtime check for this. And the function branches. Did you think about somehow eliminating this runtime check because it's overhead? If at runtime the actual loop is short, this might be a kind of significant overhead. The more so if it's a non-vectorization hardware.
I'm not Jim, but I know a little about auto-vectorization because I was asking him, hey, why doesn't std transform get auto-vectorized? And they need that branch if they don't know what architecture it's going to run on. With the right switches, you can tell the compiler, and this is true for all the compilers, that, hey, I'm going to assume my end user's got SSE 2.9, AVX 25, whatever. And then it can emit those branches. But if it doesn't know, it's got to emit that.
So
it also has heuristics, and this is where all the magic sauce happens, where if it sees like a really short loop, it's not going to try to bother. It's only going to emit that vectorization stuff if it thinks it will be a win.
There's some really cool stuff actually in GCC, which you could check out, which is essentially trying to do the same thing, but they have a slightly different approach. There's a tool in the ELF GNU loader, executable loader, called ifunc relocations. What this is that they emit two different function bodies, one supporting the modern hardware that can do vectorization, one without that support, and under very special names, and with very special relocations. And what the relocations actually say is they say, go run this program over here, and it will return the address to use for relocating in the dynamic loader. And then the dynamic loader simply updates all the call addresses to that address, which happens to be the one right for this architecture, and you get the fast performance and you don't have a branch. This actually has two really interesting impacts. One, you don't have a test, right? Instead, you just have a call site. But even that is problematic. The other nice thing is that the compiler is the thing actually choosing where to make this call. And so you can actually inline through this by every time you say like, oh, I'd really like to inline this function, but it has this vectorized loop body in it, you can simply clone the caller and do the ifunc dispatch at the caller. Right? And so you can keep hoisting this dispatch up until you're going to have a function call dispatch anyways, and you can plug in right there to get your per architecture dispatch. It's really, really neat. You can find it, it's GNU ifunc is what you want to search for.
So just so people know, I just wanted to say, Eric Broomer is going to be talking about this at 3:30 as part of his talk. Question over here.
Oh, short comment that Clang actually uses vector instructions if they're available in their lexical parser to skip over comment. It's just fun.
So Clang uses vector instructions in its lexer to skip over comment blocks more quickly. Yes, this actually has a measurable performance impact. No, it is not the same as actually exploiting the rest of the hardware.
So we're going to take a break soon. We have good. This guy.
As you said, we should stop supporting x86. So why does Visual Studio ship as a 32-bit binary?
Vote STL for World Controller in 2016, and I promise that will change.
You've got my vote.
We are looking for a CEO, I heard. Guess I'm looking for a job.
Are the shares going to go up tomorrow on MSFT?
So you guys, here's the deal. It's up to you. Do you want to take 20 minutes, get coffee, get rejuvenated? Because you're going to have a compiler talk after this. Or do you want this to keep going for another 10 minutes?
Hold on, Charles. Why aren't you asking us this?
Because you're working, man.
Take 20.
Take 20. Thank you, guys. We're done. We're going to go take a break now.